Hello everybody, today we're going to be talking about a really interesting field in mathematics, which that is exponential functions. An exponential function can be categorized as something that takes the form of, let me write it down here, f of x is equal to ab to the x power. In other words, exponent is x. As we can see here, I have done that. Let's get back to this later. This is going to be our second example. Today we're going to try to determine whether or not t-tables or functions claimed to be exponential really are exponential. So without further ado, let's begin. To categorize an exponential function as being exponential or not, it has to, this x-axis, we do x-axis or f of x, and f of x. You can either do y or f of x, but I'll just do f of x for the sake of this video to clearly indicate that it's a function. So the x-axis has to go up, has to be added as every single time by a set amount, whereas at the same time this y or f of x axis has to be multiplied by the same amount constantly. Let me show you what I mean and try to prove whether or not this is an exponential function. So -1 to 0, well, that's a +1. These other two components in the x-axis have to be +1 also in order for this x-axis to be good. So 0 to 1, -1 to 0, that's +1, all good. And 0 to 1, that's +1. We're doing great so far. And for the final one, 1 to become 2 has to be +1. So x-axis is good so far. Good. What about the f of x axis? Like I said, it has to be multiplied by a certain amount. So 1.5 has to be multiplied by 2 to become 3. And this is 2 multiplied by 2 because, oh, it's too long of a line. 2. Because 3 times 2 is 6. And 6 times 2 becomes 12. So awesome. And yes, all we have to do is write down yes, it is an exponential function. But what about here? Here I try to be a little bit more challenging because you might see these in your tests or maybe in everyday life if this is the kind of thing you're working with, perhaps economics. Economics is really where exponential functions seem to shine. So we have to make our own t-table for this, but have no fear, it's really quite easy. I'm going to label it using this different colors right now. Why don't we try the light and bright green? X and f of x. So for this exponent, why don't we try 0 to begin with? Because 0, all it is this a over here. This a, this isn't very legible. This a is this 3 number here. So if you do the math, it's, you know that 3 times 0, 3 to the power of 0, anything to the power of 0 is going to be 1, and 3 times 1 is 3. So let's try 1 this time. 3 to the power of 1 is 3, and 3 times 3 becomes 9. And as for 2, 3 to the power of 2, that is 9, and 9 times 3, that becomes 27. Good so far. And let's go try 3 the final time. 3 to the power of 3. Well, that's really quite easy. 3 times 3 times 3. If you don't memorize it yet, this is 9. And 9 times 3, that's 27. Wait, okay. I'm sorry. What I mean is that 27 is only part of it. We need to multiply this 27 by 3. 27 times 3. Let's see what we did here. Here, this. So 81. So now let's do the same thing that we did in this t-table. These all go, as I seen, they all go by 1. So we're doing relatively easy. And we could do times 3 is 9. So these two have to follow the same pattern. 9 times 3 is 27, all good so far. And 27 times 3 is 81. Perfect. So yes, this is in fact an exponential function. Congratulations, you mastered seeing whether or not they are exponential functions. And an easier way to do it, let me just show you, it has to take this format. If it takes this format, no matter what, it's going to be an exponential function. I just wanted to give you guys a real life situation and testing your knowledge in this field of mathematics so you become better acquainted with it. I'll see you in the next one.